Section 7.6 in Chapter 7 is a non-qualitative section, just a discussion. And what it does, it contrasts the differences between active and reactive power. It's called distinction between reactive and active power. And let's look at some of those ideas here and think through those as we consider this new thing that we've been introduced to. So what we find out in section 7.6 is there's a basic difference between active and reactive power. And the most important thing is remember that you cannot convert one into the other. We'll run into that in several different applications later, but they are real things. But they cannot be converted from one to the other, and they exist and function independently of each other. So in a circuit, they're treated as separate quantities. They've always been there, but we've not talked about the reactive power up to this point. We've always just focused on the active portion. The active portion is the part of the power that does what we call real work. It would heat, it would create light, it would cause a mechanical load to do whatever it does, rotate or move or whatever. So active power, is used to do real work. That's the thing that we think about. The reactive part of it is simply there to provide this, magnetic field source that allows these electrical machines to operate. At the same time, so there's that. And then at the same time, both active and reactive powers place a burden on the transmission line. And so, whereas this active power, produces real results such as heat or mechanical power or light, reactive power only represents power that oscillates back and forth. Okay? Now, he goes on to say that all inductive devices, and we're talking about electromagnets, transformers, ballast, like a ballast for fluorescent light, and there's other types of ballasts that do other things, induction motors, that they absorb reactive power because one component of the current they draw lags 90 degrees behind the voltage. Okay, they have these inductive elements in them, and the reactive power plays a very important role because it produces the AC magnetic field that these devices have to be able to operate. Okay, so that is that. And then the last thing sort of he talks about, it says a building or shopping center or even a city can be thought of as huge active reactive loads connected to the electric utility system. And the load centers contain maybe thousands of induction motors and other electromechanical devices, electromagnetic devices, and they both draw reactive power to sustain their magnetic fields and active power to do useful work. Okay, so this leads us to the next section where we study the loads that absorb both active and reactive power.